guys, today I will start a series where I'll be solving past papers, which is the oldest one, so it's 2015 and below it. Now let's start. Anyways, describe the structure of aluminium. Now, aluminium, you know that aluminium is a metal, right? But first of all, I'm sorry that it will be so hard for me to write, because I'm using like a pen right now, but it's very, very bad, so excuse me. Anyways, and we know the metals are positive ions with delocalized electrons. If you want to draw, its structure is going to be always. That's for any non-metal, not only aluminium, please, alright? And there would be a delocalized. Electron delocalized means that electrons are free in it, then that is in fact the structure of a metal. So that gives a property of a metal that it is conductive. Why? Because that free delocalized electrons, it makes the metals conductive. That's why metals are conductive. Anyway, describe the structure of solid aluminium. You're gonna say regular is actually very important, so I'd say you always write it regular arrangement of positive ions, like this, surrounded. You're gonna see how they are surrounded by positive ions surrounded by delocalized electrons, right? That's exactly it. Surrounded by, you can skip this part when I write it, since if you already know it, delocalized electrons. So you should understand this. Now, a common use of aluminium is to make conducting cables in a long distance overhead power lines. Conducting, I told you, when you talk about conducting, you'll be like, what makes a metal conductive? Straight up, the electrons, right? So they said here they want two properties, so you can say that it is an electrical conductor. You're gonna say that's a property of aluminium, a metal. And you can say that it is ductile if it is in a long distance. You can say it is ductile. Ductiles mean that it is drawn into shape. Anyways, the cables are attached to pylons by ceramic supports. Describe the structure of ceramic material. So if it's used for supports, I'd say it is a giant lattice or a giant structure, because in the mark scheme it said giant slash lattice, so you can use whatever you want. Giant lattice. This is the keyword. Giant structure or a lattice. Anyways, state the property of a ceramic material that makes it suitable for use. Okay. The cables are attached to panels by ceramic support. Look, here is actually more about understanding. Just understand that it is used for insulating. You can, when you read the question, you can understand why is it in ceramic support. To be like, yeah, must be an insulator to not allow electric to come to our hand or whatever. Now, aluminium reacts with chlorine to form a white solid chloride that contains 79.7 chlorine, and sublimes means that it is changed from solid to gas. Describe the structure and bonding in this. You want the structure and bonding in this compound form with aluminium and chlorine. Suggest how it explains the low sublimation. Now, this is a very important point, that it has a low sublimation. Cl3. Okay. I want you to learn that this is a covalent compound, which is a simple covalent compound, and this actually contributes that why it has a low temperature. Alright, and now this is a point that it is a simple covalent or a simple molecular compound. And you're gonna be like, the bonding, why it has a low temperature, like for this sublimation to happen. Now, and I'm sure you know, you went across this, that it has weak intermolecular forces. I wanted to learn, when you're talking about like simple covalents, especially simple covalents, and what makes it weak is the weak intermolecular forces. So you really just should learn it at this point, alright? Very important to know that weak intermolecular force. Actually, by the way, the intermolecular forces are only in covalent structure, so I don't want you to go and think that intermolecular forces are in ionic. That's wrong. It's only in covalent, alright? Calculate the empirical formula of the chloride you must show you're working. The chloride, right? AlCl3. Now we know that there are steps for to calculate the empirical formula, which you should learn. Okay. You have. Sorry. Al and Cl. Now we have the percentage for chlorine, which is 79.7. Now we're gonna be like we don't have for aluminium, but we know a percentage fully is 100, so 100 minus 79.7 equals 20.3, which is for the aluminium. Hopefully you understand. Now divide by their molar mass in the periodic table. Just take them from periodic table, and then unfortunately, let's move it a bit. Great. Alright, is that fun as you guys? Hopefully you can answer me. Anyways, so your answer for here will be 0.752, 2.25. That was the first step. Now second step is where you will divide by the smallest number you got from both. So if you use your mind, this is smaller than this, so divide both of them with the number that you got, smallest number that you got, 0.752. At the more scheme you can go in, and anyways, you have 1 3, so we said the heat aluminium is 1, chlorine is 3, boom, oh my god, AlCl3. Alright, at 200 centigrades, 100 kPa, they gave you kPa, so use your mind, Pa straight up. At 1 Pa gave you the mass as well. Great. Add this chloride compound of volume of 200. Great. Calculate the relative, they want the MR, where they see that they gave you a pressure and temperature. You use your big mind and straight up use equation. PV equals nRT. P, pressure, V, volume, N, the moles, R, N is 8.31, which you should learn, okay? And T, we know that is the temperature, alright? And the very important thing that I wanted to know, the temperature in here should be always in K, and N is in moles, we know this. V in meter cube, which is very important. Pressure in pascals. Okay, then after this we say, now that you know the units of every single thing, now you're gonna wonder, why is there no MR? But we know that, look, in this equation there's no need to use this. I mean, in this question, no need to use this equation. So you're gonna focus in N equals MR, so you can substitute in N and make it instead PV equals N, which is here equals to m equals mr, and then the rest of the equation. But now still they only want for mr, not m. That's why you should move them to, you should move all of these to make them in one side of the equation and mr's in the other side. Now you can actually just learn this and finish yourself. mr equals m, the mass, rt, PV. But there's also a way for you to learn how to do it. I mean, instead of learning, you can understand how to do it steps by steps, but I really prefer you to learn it. But if you want the steps, you can do it. You know, PV equals an RT, right? PV equals M over M, sorry, MR, RT. Now you want M, right? Now, before changing them, I'd say, first thing, before changing them, you can use this equation. This, I'd say, an equation, a diagram more like it. Alright, PV equals nRT. So you want for n, right? N equals PV over RT. It's really just, you need to understand the use of the triangle. It's really very easy. So this shows the divide sign, so it's exactly what I mean here. Right, so now you have for n. Now again, m over mr, which is substituting of the n. PV RT. Yeah, so you can't just move the m to the other side because it really does not work like that. So you should switch their places. So once you switch your places, you're also gonna switch the other side places because they are, it's a complementary to each other. mr over m equals rt over pv. Now you can switch, now you can move the m to the other side. So it was here divide, it was divide m, so it's gonna be now multiply m. So your final, I'm sorry, mr equals rtm divide pv, or mrt, whatever. So this is the exact same thing as this. You can either learn it and finish yourself, or you can do all of this. But as very as actually, it's not that hard, to be honest. You just need to understand that it's fine. Now after you finish the hard part, now the easy part is just you need to substitute and make sure that you convert everything. Now it was here in centigrade, so if you want to change centigrades, I know I'm saying it very wrong, but who cares, into Kelvin, as Kelvin is a unit that we want, you need to add plus 273, which is 473. Now 1 kPa, you want to change kPa into PA, so multiply 1000, again learn them. Gram is gram. Anyways, 200 centimeter, you need it in m cube, centimeter cube to m cube. You need to learn this once again. Now a trick for you is centimeter. You can again learn it or understand it again. Centimeter to m, we know that it is from small to big is divide. Centimeter to m is divide 100. But now since you have centimeter 3 to m, so you're gonna add 3 times. And that is exactly how you'll change centimeter 3 to m3, so just you do them. And the answer here, look at the brown skin, by the way. 200 multiplied 10, because I don't have the calculator right now, so I'm just using the mark scheme. Yeah. Now the easy part is go on. Now you can put everything in place. Now now you have here the mass 1.36, multiply the r, which you should learn, 8.31, multiply the t that we added to the centigrade 273 to give 473. Alright, and then go on. you have the volume. Where's the volume? This is the volume. 200 multiplied 10 minus 6 multiply, what do we have? Rest the pressure, which is, we divide by 1000 to have it in pascals instead. 100 multiplied 10 which is 1000. Now you put them all together and your answer is 267. Hopefully you understood it all. Alright, great. Sorry. Now, did use the molecular formula of this chloride at 200. Now, they give you here the molecular formula. Anyways, now the molecular formula is, you need to use the empirical formula from it. Now, you know the empirical formula here is AlCl3, right? Now you need the MR of AlCl3. Now you just need the periodic table for this. Out of the periodic table, let me check once again, I'm sorry. Okay, so Al is 2.3 and Cl is 79. That is not it. Al is 57, Cl is 57 and 35.5. You're taking from the periodic table, by the way. Al 27 plus 3 times of Cl, which is 35.5. We need to calculate your weight in minutes. Okay, I'm done, which is 133.5. So here you found the MR of the empirical formula, which is the simplest formula. Now you want the formula without any simplifying, which is the real formula. So you need to use what you found. So you need the MR of whatever they gave you with the MR of the empirical formula. So it's very easy. What you're gonna do is 267 is what you calculated. Divide 133.5. Wait a minute. Which is 2. So 2 is the number that you will multiply the empirical formula with to get the molecular formula. So it's gonna be here Al2. 3 multiply to 6. So your answer is AlCl6. Great. Hopefully you guys understood everything so far. Okay. Explain the meaning of the term enthalpy chains of formation. Here you should learn. Again, my handwriting is really not it. So just go to Marsky. That it is the enthalpy change. You need to always write the enthalpy change. You need to always repeat it once again. I don't know why, but it's very, very important. It's enthalpy change when 1 mole is, again, very, very important, when 1 mole of a compound is formed from elements. That's the end of the mark scheme, but also add in from element in standard states. Great. You should learn it. You want the formation of a liquid sulfur dioxide, so I want you to learn, to be honest, okay? So you can just add S plus O2 to give you SO3, and they won't include the state or your mark will be gone. Sulfur is solid, oxygen is gas, SO3, need to learn, is liquid. And you balance based on the question 1/2. Alright? And by the way, the 1/2 here shows that need, okay. For you, if anyone actually get confused, because I used to be confused with it, so basically what does the 1/2 means? 1/2 first thing, 1/2 multiply 2, you have how much? 1. And then plus 1 multiply 2, which is 2. So it's 2 plus 1 equals 3. So the side here has 3 oxygens, and the product side has 3 oxygens, and this is how you balance it. Alright? Now, these questions are cute, to be honest, so really Enjoy. Anyways, ammonia is manufactured by the Haber process. Use the bond energy from the data booklet that will be given to you in the exam timing, so don't panic, to calculate the enthalpy change of reaction. Enthalpy change of reaction is always the reaction that they give you. Okay? For the Haber process, include a sign in your answer. Alright. Okay, we don't have the booklet right now, so it's okay. We live. Now, the equation that you need and want to learn is always reactants minus products. Look, I know usually in this type of questions they give you that you need to use this stuff, whatever it is, but in questions where they instead give you the bond energy of the entire equation, so it really just need to use this reactants, which is this, minus the products, which is very, very, very easy, and this gives you the enthalpy change. Wow, that's not the sign. Don't come for me, please. Nice. So now you need the bond energy of everything. Now N2 is gonna be given in the data booklet, which I do not have, unfortunately, so it's 944. Plus, you have 3 of the hydrogen bond energy, which is 436 in the data booklet, minus a product, which is how much? 2NH3. Now you will come for me for sure, I know it, because we need the booklet right now, but please don't understand it, because I don't have it. I'm for sure I don't have it. Now they will give you the bond for NH, right, and then the booklet. Now since you have 3 of them, so it's 3 multiplied the bond energy of NH. What is this? Of NH, right? From my data booklet, and now whatever your answer will be, will be multiplied too, because you have 2 of NH3, and the answer here is 2240. Alright? It's very, very easy, please, just you understand it, okay? So you plus the reactant side together minus 240, which is minus. Minus means it indicates that it is an exothermic reaction. I write it here. Hope you understood. Now state the essential operating condition for Haber process. I mean, I remember Haber process coming in the A-level, but I really don't know. So again, you learn it. I remember for the IGs, because it was the IGs. Always the iron catalyst, 200 pressure, which is an ATM, 400 to 500 centigrades. Great. Okay. Explain the choices of temperature and pressure for the Haber process. Alright, so this question, I read the mark scheme, really kind of confused by it, but okay, whatever. Explain the choices for pressure and pressure. Alright, so I'd say the first point says that high temperature increases rate, which you know it, so we're gonna write temperature always increases rate when you increase it, and low temperature improves yield. Oh great. Why? Since your equation is exo, and when you reduce the temperature, there's this trick, by the way, since if anyone is interested, will be great. So it is the product side, reactant side, product side. So when you reduce the temperature, it will go to product side. So it's like, reduce, go down. That's my trick, by the way. So that's why it will improve the yield of NH3, so that's why you will write it here, which is there. I don't know why, but they're the same mark. Well, it says and, so you should add it. And low temperature improves the yield. Improves yield of NH3. Alright. Now chosen temperature is compromise, which I don't know what is this. Which I'm sure will not come for you because I don't know, it's literally cancelled, but okay. Temperature is a compromise, so I guess you change it. Look up for me, please. A high pressure favors. Okay, now the pressure gonna speak. Okay. Now pressure, we know that pressure favors pressure. I mean, it's high pressure favors the side with less moles. Alright, so here you have 1 plus 3, so you have here 4 moles in the reactant side. You have here 2 moles the product side. So here they said high pressure favors. Yes, okay, before we explain, you know, again the pressure. High pressure favors the rate, because when you increase pressure and increase temperature, it will increase the rate. Learn it, please. So when you increase the pressure, it will favor the side with a lower mole. So that's why it says here it increases both rate and yield when you increase the pressure. And it's also the same mark, and yield. That's why. Now pressure chosen, limited by cost. Okay, great, whatever it is. Now, alright, one of the major uses of ammonia is in the manufacture of fertilizers, and okay, write an equation for the formation of the ammonium hydrogen phosphate reaction. Alright, how great. So between ammonia and the phosphoric acid. So ammonia is NH3 plus phosphoric acid, which is H3PO4. They gave you the answer, which is so kind. Now the only thing you're gonna do is just to try to balance it, just hopefully know how. Hopefully, crossing fingers at this point. How wonderful. Okay, explain this reaction in terms of burst and lower. I don't know how to read it, but okay, you get it. So, first thing, you need to know that ammonia is a base. Learn it. It's basic, you can say. H3PO4 is clearly an acid. Now, first thing you say, you mentioned that it'll give you a 1 mark for this. NH3 is a base, and H3PO4 is an acid. Alright, now that's a 1 mark. The second mark we know first. Okay, you can either learn, I mean, you can either like already notice that you know that the base is a proton acceptor and acid is a donor, means it donates the proton. Protons in this case, it's an H. Oh, it's an H. Alright, so why we said that. If you don't understand it, why? Ammonia, you're gonna see that it has here an NH3, right? That was the reactant side. Now, if you look at the product side, it became an NH4. So it had an H plus added. H plus here is the proton added. Oh, you guys look out for me right now. Alright, H plus. indicates the protons. So here, that's why since NH3 is converted to NH4, it shows that it is in fact basic because it accepts protons. So that's a point for now. Second point is they said here that H3PO4 is an a proton donor, because you can clearly see that it was here. H3PO4 became HPO4, so H plus is removed. That's why. You're right. The base, just ammonia, accepts protons. I'm very sorry. And acid H3PO4 donates protons. Great. The use of nitrate fertilizers can give rise to environmental consequences in terms of explain how the uncontrolled use of nitrate fertilizers, I don't know how to speak, can result in a severe reduction in the water quality in rivers. I should actually learn it how it works. So how it works, to be honest, just quick sketch. You have here the water, right? So if there was if there was an excess of fertilizers going into the water, alright, so that's the first point, that nitrates fertilizers wash into rivers, which is the river it goes, there was access, really don't want it, so it's actually causing harm instead. So that some kind of algal bloom will be forming on top of the water, and that unfortunately will actually affect a lot the plants in here, so they won't be able to photosynthesis because it was blocking. Okay, so there will be no oxygen formed no more as it photosynthesis, so the fish dies. That's why it's that harmful. So now you need to write the points. Nitrate, actually it says skip it because it's too much bird. Into rivers. Now the process that happens is actually this, which I don't know how to say it. Eutrophication, I don't know. Or you can say algal bloom instead. Algal bloom growth. Algal bloom growth is what prevents all the stuff. And then bacteria use up oxygen in decay process. So in this case they said that it is the bacterias, or you can say the animals, because they also take oxygen. But why I'm gonna say is because, listen, since the plants die, the bacteria will be feeding on them, and we know the bacteria, it respires aerobically, so it needs oxygen, so it will reduce the oxygen. Oh yes, and that's why the fish dies. And it's also in the IG biology, that's why I'm explaining based on it, but you can based on this as well, which also is correct. Anyways, oxide of nitrogen are produced by the actual bacteria or nitrate filter. Explain the problems associated with the release of nitrogen into the atmosphere, include an equation in your answer. So what does oxide of nitrogen actually do? Oxide of nitrogen, it will cause acid rain. Now you're gonna be wondering how, that's why they include an equation to conclude it. You can write nitrogen dioxide will react with water to give you HNO2 plus HNO3, that's based on the Mark scheme. Now, other than this, you can say or. Which is the one that I prefer the most? Sulfur dioxide plus nitrogen dioxide will form sulfur trioxide plus NO. Alright? And then the SO3 will dissolve in water to give you sulfuric acid. Harmful. Which causes the acid, you know. Great. Even though that question is talking about nitrogen, you can either talk about this or this, because here the nitrogen contributes to give the acid rain, so you can also write it. Now we are in the danger area. No, it's actually easy. Organic chemistry is easy, personally. Just need to practice and practice, you will go through it, trust me. Alright, heptane. Also a trick for you to know that it is an alkane or alkene. Always multiply the carbon with, example, you have 7, almost multiplied with 2, you got 14. If the hydrogen amount was the double of carbons, means immediately it's an alkene. But in this question, let's look at the question. If you multiply it by 2, and you got 14, but it's also plus 2, then it is in fact an alkane. If the hydrogen number is double the carbon plus 2, for example, is 7 here, it's double 7 is 14 plus 2, which is 16, so it is an heptane, an alkane, right? CN H2N plus 2. That's for alkane. Alkene CN H2N. Basically, that's all. Okay. Alright. There are non-structure. Oh my god. Non-structural isomers. Very important. Structure. With the formula, okay. Only 2 of which contain chiral centers. What is a chiral center? Is a carbon connected to different I don't know what I'm saying. A, B, C. A carbon connected to different groups. Like you can't just go and write, for example, H a hydrogen. That's wrong. So it's not a chiral carbon. Chiral carbon that has like different groups. Alright? Explain the meaning of the term structural isomers and a chiral. These questions are actually very, very repeated, so just learn them and understand them for sure. It is molecules with same molecular formula but different structural formula. What do I mean? That they have the same molecular formula, which they actually proved that they said they are non-structural isomers with the formula 7H6. So there's different structural isomers. That's why we said different structural formula with the same formula, which is the molecular formula. That's exactly, they proved it in this sentence. Great. Now our chiral, I'm sorry, the same exact thing in here. It is has a carbon attached to 4 different groups. Okay? Now, give the structures and names the two structural isomers which contain a chiral center. Okay, what do you have a heptane? Now, in such questions, I want to start to draw this, whatever they give you in the normal form. 4, 5, 6. Oh, and that's a lot. Okay, done. Now you can choose any carbon right now to say that it's a chiral carbon. But look, the problem here is the problem here is that whatever chiral carbon you choose, instead of choose this, same, different, this, same, this, same, this, same, until the end. That's why if it was unbranched, in this case, by the way, no chiral carbon, right? So again, the non-branch will not work since they all have the same group. Every single carbon have the same group. But what if I'd say that I want to change this place? I want to change this carbon, this CH3, into somewhere where I can make it chiral. I want to move this, for example, here. Now, quick thing. Why will it not work? Think about it. If you switch the CH3 and you put it in here instead, you're gonna see. Now, forget this for quick. Forget this since I moved this part to here. Now, it is still not a carbon chiral. Why? Because the carbon is connected to CH3. Sorry. Carbon here, this carbon is connected to CH3 on the right side. Up is also CH3. So this form is not chiral. So again, that was wrong, so I want to change this place to somewhere else. What if I change this and put it here instead? Let's check. If I put it here, CH3, and now we're gonna delete this so you won't get confused. So I delete the part where I moved it here. Now edges here. Delete this. Alright. Now let's check if it worked. So this carbon is connected to CH up here to this entire thing. You take the whole entire thing, by the way. Down you have CH3. Left side you have 3 carbons with their hydrogen. So is it chiral? Yes. Why? Because they're all different groups. You have here C2 H5, and here you have C3 H7, and down you have CH3 and H. So they're all different groups. So yes, you can add this to your collection, whatever you want to say. Alright, and now they want the names. We're gonna keep this for later, okay? Later is the names. Alright, now you want that, this said that you want 2, so I'm gonna make 2, just the first one. Now second one, I'm gonna do the exact same thing, so you won't get confused if I want to do it again, right? So let's do it. Okay, so we did this new compound once again. I mean, the exact same thing, so I can explain it for you guys. Now, the thing I notice about people that they do this, they think that this will be correct. So what if you move the CH3 and you put it, let's say, here, which is actually sensible, because if you think about it, so you're gonna get now CH3 is moved into here, right? It is gone since you moved it, right? So you're gonna say, yes, I cooked. Why? Because this carbon is connected to different one you have here, different one. See, 2 carbons in here, 3 carbons on the other side, a hydrogen here, SCH3, which is actually correct, right? But hey, you did this before. Why? This exact same thing as this. That's why if you draw them 2 times, you will not get the mark for the other one. Okay, why? Because let's read it. When you count the carbons, you count from the nearest side to the branched point. The branched point, this diagram is CH3, right? So when you count, you don't count like 1, 2, 3, 4. Like CH3 is connected to the 4th carbon. Wrong. You go to the nearest side, which is this nearest chain, which is 1, 2, 3. CH3 is connected to the 3rd carbon. That's how you count it. Same thing with this. You don't go counting from the longest chain to the CH3, which is this. You don't go 1, 2, 3, 4. That is wrong. You go count from the nearest side, which is this 1, 2, 3. Found it. CH3 is connected to the 3rd carbon. So you're gonna see that this is CH3 is connected to the 3rd carbon. This is also connected to the 3rd carbon. So this is the same thing. So you won't get the mark, unfortunately. Now you need to again play with it. What if I again moved a carbon chain and I put it in, let's say, to the 2nd carbon to give me CH3 here. Forget about this. And this still not the answer, since you have CH3 here and CH3 here, so it's wrong. What if I again moved something else? What if I again moved and I put the CH3 here and I put it near the other one? So do you understand the thing I'm doing is basically playing with it until I get the answer. Now let's check. Alright. Now, okay. So if you chose this as the chiral carbon, it's gonna be wrong. Why? Because again, CH3 is wrong. So it's not your go carbon. What if I chose this carbon instead? Let's see. You have here an H bond up, a CH3 bond down, this entire thing, and this entire thing. These two are different because we have here a CH3, that's why the CH3 came in handy. So yes, that is the second isomer. So again, you put this here. Alright. Now for namings, it must be easy, alright? Don't cry yet. Again, I told you to count from the nearest side because you always, you name it first by its place, the branched, and then the rest of the chain, which is this. Okay. Count it. 1, 2, 3. So this is called methyl. A CH3 as branched is called methyl. Learn it. So now where's this methyl? In which carbon it is connected to? It's connected to the third carbon. So 3/methyl, and then you put the rest of the chain. 1, 2, 3, 4, 5, 6. So 6, which is hexane. You named it. Great, good job. Now the second one. Again, you count the methyls, CH3. So you have, in this case, you have 2 of them. So we know we're gonna say there is dimethyl. Dimethyl means that there is 2 methyl groups, just like here. Now, but it's not the case, and that's only this. You're gonna read it. Again, the closest carbon place. So let's talk about this one. You have 1, 2. So this one is in the second place, and that one is in the third place. 1, 2, 3. So how do you name it? There's 1 methyl in the second carbon, other one in the third carbon, and then slash dimethyl, as there are 2 methyl. Then last thing is the entire chain. What is the entire chain? We have here 1, 2, 3, 4, 5. 5 is a pen. So it is an alkane, so it is a pentane. You named it. Great. Now you got 4 marks. But hey, I know that was a lot, but trust me, I here explained in details. But on the question, you're gonna do it in like 2 minutes max. Trust me. It's actually very easy, but like here I explained everything in details. That's why it took a lot of time. Write an equation for the complete combustion. Combustion is always CO2 plus H2O. The only thing I'm gonna do is actually just like balance it. That what matters. The others you need to learn. C7H16. Okay, look, I'm not balancing here because you really need to learn how to balance. Plus 8H2O. Write an equation for the incomplete combustion. Instead of getting CO2, you'll get CO. That's what I mean by incomplete combustion. Refer to the mark scheme for this one. 4O2, 7C, and this question they said carbon. Okay, so incomplete combustion can be either CO or carbon. It's actually based on you, to be honest. But I guess since we're talking about you're an alkane, you should write about carbon. So okay. Anyways, incomplete combustion can lead to emission of unburned hydrocarbon state. One environmental consequences of this. Learn it. With PAN. We're gonna say global warming. Global warming. Okay, now you're in the substitution of alkanes. Name the mechanism of this reaction between heptane and chlorine. Between heptane and chlorine, this is free, not really necessary, but radical is very, very necessary. Radical. What type of reaction it is? A substitution reaction. Why? Because the Cl takes the place of a 1 hydrogen to give you C7H15Cl. That's with substitution. Why is it a radical? Because the Cl initiates into Cl radical and another Cl radical by homolytic. I don't know how to write it. It's that fission. Okay, Describe mechanism using equations, including, okay, and this is actually very important. We need to learn how to do it. First thing, Cl2 initiates into Cl plus Cl. So they had the bond, right? An equivalent bond, one takes that, one takes the other, so alright. Now this is the initiation part. Now you have the propagation part. First thing, in the equation they gave you C7H16. C7H16 reacts with one chlorine radical, which are formed by these, the initiation part, to give you C7H15 radical once again plus HCl. Trust me, with practice you will actually memorize any type of questions about this, so really you should learn. But something to learn is that, or understand actually, is first thing, initiation, it gives you two radicals. Propagation is where it is a grounded one reacts with a radical one to give you a radical one plus a grounded one. So it's never like both at the same time, you know. It's for the propagation parts. Okay. So what happened is basically C7H16 becomes C7H15 radical, and then the hydrogen from the H16 came into the Cl radical to give you HCl. First one. Now this again will be reacting C7H15 radical will react with a normal one. As I said, it's always radical one, normal one, to give you radical one, normal one. Again, the reactant part will be radical one with a normal one, which is the Cl2 in this case, to give you C7H15Cl plus a radical one, as I told you. Never the two in the same time. So how it happened in here, basically a Cl will react with this entire thing radical to give you C7H15Cl, and then remaining will be a Cl radical. Now this is basically the propagation part. Now you have the termination part, which basically is like you need to add all the radicals. You have the C7H15 radical. You have also the Cl radical. Basically, you add them all together. You can either add 7H15 plus radical, by the way, plus Cl radical to give you the entire product CH15Cl. You can have these radicals, or you can also have other radicals together, which is C7H15 together, each other, C7H15. You just add the carbons all together and the hydrogen all together. If you add them all together, you're gonna get C4TH30. You understand? And basically, these equations do all each step to give you these products, as you can see. Like C7H15Cl was the product at the very end of the termination, which is this. So it's really that, and it's actually very easy. Okay, this question they said give an equation for reaction 2 includes the region. Now what word will we use first thing? Reaction 2 is from an alcohol into an halogen alkane. So let's draw it real quick. CH. Alright, CHH, and then OH. And then we want to change it into CH3 to CH. So here it will be from an alcohol into an halogen alkane. So here you have an alcohol and you're gonna change it into an CH3CH2Cl. So if you notice here it is the exact same thing, but there's a change from the OH to Cl, so this is in fact a substitution. Nothing's added, just substituting. So you need to think of a region that will be able to say we use HCl. Alright, so the mechanism will be HCl. Cl is more electronegative than H, so it will take the electron to be here H plus and Cl minus. Now here the OH is more electronegative than carbon, so it will take the pair of electrons shared between them both, so the OH will go. And now after it went away, now the carbon will become a carbon cation, whatever you want to say. So now carbon cation will want any charged thing to come to it, so Cl minus will be there. Cl minus, okay, Cl minus will go and attach into the carbon cation to give you, as they said, CHH2. Okay. And now the remaining of it, as there is an OH minus right now remaining, the OH minus will go into the H. So OH with H will give you an H2O. So that's exactly the mechanism that you should learn, and now just can water down C to OH in the form of an equation other than a mechanism. HCl is the region that you chose. There is PCl5 instead, SOCl2. PCl5 is, I'm sure you guys are familiar with, but in this case we used HCl because it's mostly what is familiarized in such thing. Alright, state the reagent and conditions required for reaction 1. What is reaction 1? Reaction 1 is it's the opposite, which is from an halogen alkane into an alcohol. Now you should learn it. Halogen alkane to alcohol, it must be an aqueous base, and this equation is a nucleophilic substitution reaction. So the reagent is any base in AOH or KOH. Conditions, you can use, I'd say, heat or warm or in reflux, and in aqueous. So you add to this, it is in reflux. Alright, there's also another one when hydrogen alkane goes into an alkene. It is an alcoholic base, which is an elimination reaction with reflux. Anyways, identify the organic product X. Let's see. That was what I was talking about, that halogen alkane with the use of an alcohol and base heat in reflux to give you an alkene. So what alkene gonna get? We have here an we have two carbons, so it's gonna be an ethane. Okay, and the question they said an ethane as well, but you need to learn it is an ethene that is formed. Okay? The question gave both ethane and ethene, I don't know why, but the correct answer is ethene and alkene. That is the equations, that is one of the equations of the halogen alkane that you should learn. And nitric acid is added to products of reaction, C3 occurs in NaOH and ethanol. Silver nitrate solution is then added to this mixture, so just state what you would observe. There you should learn what precipitates. Next question, we have triple I. It says write an equation including state symbols for the reaction responsible for. Now it's actually just use your brain. Ag plus, since you want an ionic equation, AQ plus Cl minus AQ again, AgCl, which is a solid, which is the white precipitate. Identify the organic product Y, which is distilled. Straight up, when you see distilled, you'll know it is an aldehyde. Let's check. Y here is an alcohol is oxidized into something. Now we're gonna wonder, did it oxidize into a carboxylic acid or an aldehyde? This shows it. So it's in fact an ethanol. And by the way, one alcohol, which is CH, OH. One means that OH is connected to one carbon only, and the one alcohol is either oxidized to carboxylic acid or ethanol. If it oxidizes into carboxylic acid, you should say reflux, but for aldehyde you should say distilled. So the product is this or ethanol. Explain in terms of properties of intermolecular forces in the alcohol and Y, which is the ethanol. Why the chosen condition for reaction? Okay. Why did we distill it, and what is the reason this is, and like how? First thing you should know that the alcohol CH3CH2OH has higher boiling point than the ethanol. Why? Due to because an OH here is a hydrogen bond, and hydrogen bonds are the strongest bonds among all the other intermolecular forces, which you should learn, bonding in ethanol. So stronger intermolecular forces. And the thing is that why did we use the condition of why do we distill it? Because the ethanol has a very low melting point or boiling point. So because it has low boiling point, so the low boiling points will be distilled, okay, and the one with very very high boiling point will go further into reflux. Get it? So why did we use the condition of distill? Because an aldehyde has a low boiling point, so it will be distilled. That's why you will be able to get an aldehyde. You will be able to get an aldehyde because it has a low boiling point when you distill it. So it prevents further, because if aldehyde did not have a low boiling point, distillation will not work and it will further oxidize into a carboxylic acid, which we do not want it, which is in reflux. That's why we dissolve it. Yeah, that's it. Anyways, thank you for watching.